Hello there, everybody, and thanks for joining me again for today's lesson. Today, the I can statement is, I can understand the probability of compound events. Now, we don't have a notes page today, we just have our assignment page. So we're going to be working together on our worksheet for today. And if you don't mind, just find some little space on your worksheet where you can write that I can statement for me. That would be fantastic. Since we're talking about compound events today, let's talk a little bit about the difference between compound events and simple events. So with simple probability, that is the likelihood of one event occurring. Maybe you flip a coin one time, or you draw one card out of a deck, something like that. Now with compound probability, that's the likelihood of two or more separate events occurring. So maybe with a compound probability or a compound event, you would first flip a coin and then draw a marble out of a bag. Or you could even flip a coin and then flip another coin, something like that. But there has to be at least two events. There could be three, there could be four. And the more there are, the more complicated it can get. In today's exercises, we're going to be doing up to 3 events in our compound probability. Okay, so let's get started. Let me get this out of our way. Okay, so it says sample spaces and probabilities for compound events. So we're going to be figuring out all the sample spaces for some compound events. And remember, sample space just refers to all of the possible outcomes that could happen when you have these setups, these different things that we're doing. In this case, there's games that are being played where you could win or lose. Let's read. The tree diagram to the right, okay, tree diagram, that's this thing. See how it has like all the little branches? So this is our tree diagram. It shows all the different outcomes for a team that's playing 3 games. It doesn't say what kind of game. You could think of basketball or any other game that has either a win or lose at the end. Okay, because see, that those are the only 2 possible outcomes. When they play a game, it's either win or lose. It says to complete the list of outcomes and use the sample space to find the probabilities for the compound event. Okay, let me make a quick note for those of you who don't have a printer at home. What should you be writing down right now? That's a really good question you might be asking yourself already. You do not have to write down all of these words, okay? But I do want you to write the tree diagrams. You don't have to write the whole word win. You could write W and L if you want. So WL, WL. But you do need to have the tree diagrams and definitely this list of outcomes. Okie dokie. So let's keep going. So complete the list of outcomes. When they say that, they're talking about this right here. So let's take a closer look at this tree diagram. So for game 1, there's just 2 outcomes for game 1. They might win or they might lose. Now after game 1 is over, they're going to go and play another game. And for that game, there's only 2 outcomes, win or lose. So they might win game 1 and then lose game 2, or they might win game 1 then win game 2. Over here's what happens if they lose game 1, then they could win or lose game 2, right? But that's not all. There's also a third game, and that game might be won or lost. So they might lose game 1, then win game 2, then lose game 3, or any of these other possible combinations. And that's what we're going to write out right now, is all the possible combinations, all the possible outcomes that are in this sample space. Okay, so for the first one, they're going to win, and then they win again for game 2, and then on game 3 they win again. And this one's done for us. We have WWW. That just represents win, win, win. Try to save ourselves a little time not writing the whole words out. Let's figure out what's going to go on the second line. We're just going to kind of follow the lines here. Win, win, loss. Okay, so this one we're going to write WWL. Okay, what about this third blank? Starts with win, then it goes to loss, and then it goes to win. So win, loss, win. And now for this next line, win, loss, loss. So win, loss, loss. Okay, we're halfway through. Let's keep going. Now, following it backwards, we're starting with a loss. This one will be loss, win, win. Loss, win, win. This next one will be loss, win, loss. This next one will be loss, loss, win. And the final one will be loss, loss, loss. And if you need to pause the video and catch up, just go ahead and do that. Do whatever works for you. You've got plenty of time. Now that we've filled out all the blanks here, we need to answer some of these questions. So again, if you don't have this printed out, just write number 1 on your page, okay? So for number 1, the total number of outcomes. Well, we're just going to count over here. 1, 2, 3, 4, 5, 6, 7, 8. Well, we listed 8 possible outcomes, so we're going to write an 8 right here. Okay, now what is the probability that we're going to win all the games, that this team wins all the games? So we're looking for a win-win-win here. And it looks like there's only one. It's that one at the top. So there's only one way to do a win-win-win out of 8 possible outcomes. So we're going to write 1 over 8. I'm going to scribble that out. I don't really need a 1 there, and it might confuse me later. Okay, so for problem number 3, what's the probability of exactly 2 wins? Exactly 2 wins. I'm going to go through and mark them with a 2 if they have exactly 2 wins. This one has 3 wins, so I'm not going to mark it. But this one has exactly 2 wins. This one has exactly 2 wins. That one has 1 win. This one has 2 wins. And 1 win, no wins. So it looks like we have 1, 2, 3 where they have exactly 2 wins. So we're going to say 3 out of how many? Total number of possibilities, which was 8. Okay, and then you're going to go through it the same way and figure out at least 2 wins. So that might mean 2 wins or it might mean 3 wins, okay? And then for exactly 1 win. I'll let you work on those. In the next one, let's see, it's a big old tree diagram we have there. It says the tree diagram to the right shows the different outcomes for the compound event of flipping a coin, spinning a spinner with 5 sections, all these different colors, red, orange, yellow, green, and blue, and then flipping another coin. Okay, so we flip a coin, we spin a spinner, and then we flip another coin. All right, got it. Complete the list of outcomes. That's this business over here. And use the sample space to find the probabilities. Okay, this is the sample space also, okay? These are all the possible ways it could turn out, so that's the sample space. We're going to go through with a similar method. It's just a little more complicated because there's more options. You know, in the top one, it was always just win or lose. But here you have the red, orange, yellow, green, blue. That's 5 different outcomes for the spinner. So it kind of makes the tree diagram a little bit bigger. So for the first possible outcome, we have heads, red, heads. So we just write HRH. For the next one, we're going to do heads, red, tails. So we'll write HRT. Okay, for the next one, and if it helps you to follow it backwards, you can certainly do that. Heads, orange, heads. And then next would be heads, orange, tails. Okay, let's keep going. Heads, yellow, heads, HYH. Heads, yellow, tails, HYT. And again, if it's helpful, pause, fast forward, whatever works. You might want to pause and do all of these yourself and then kind of fast forward till I'm done. Whatever makes sense to you, okay? Heads, green, heads. Heads, green, tails. Heads, blue, heads. And then heads, blue, tails. So you kind of have a pattern here. You notice that they're all starting with H's, right? But that's about to change because we're halfway through and we're going to start off now with what if the first flip was a tails. So it's going to start off with a T for all of these, but then the rest of them should be the same. We're going to start off with tails, red, I can't talk anymore. Tails, red, heads, and then tails, red, tails, TRT. So it's basically going to be, if you took away the first column, these last 2 letters are going to repeat all themselves, except the first letter is going to be a tails, because we're going through that whole cycle again, except with the tails in front. So if that helps, use it. If not, just keep following the arrows. Whatever makes sense to you is totally what you should do. When you have that all finished, you might look over here at number 6, total number of outcomes. I don't have it completely filled out, but I can still count the number of spaces. Let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the first half. So it should be 20. I'll keep counting. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 possible outcomes. So that's going to be the bottom number for all of our probabilities, right? So what's the probability of getting red? Well, I probably should keep filling this out to be sure, but you know what? I filled it out through the second red, and from here on down, there's just orange, yellow, green, and blue. So is there going to be any red in these? No, there's really not. So I'm just going to go through and mark the ones with red. There's this one, that one, orange, yellow, green, blue, and then this one and that one. So there's just 4. 1, 2, 3, 4. So we'll do 4 out of 20. Make sure you simplify, and it's 1/5. Okay, I'm going to let you work on 8, 9, and 10 by yourself, but again, just to be clear, exactly 1 head means exactly 1. At least 1 head means 1 or 2 heads. Both would be good. Okay, let's look at our class elections down here at the bottom. It says class elections are being held at Bingham High School for the upcoming school year. Ben and Kylie are running for president, and Mike, Emma, and Adeline are running for vice president. So if you're guessing that you're going to have to make your own tree diagram, you are correct. Good job. Number 11 says, create a tree diagram and determine, that's not supposed to be 2, that's supposed to be the. There we go. And determine the total number of possible outcomes. Okay, so in our tree diagram, the first kind of column will be president, and the second one will be vice president. Now, save yourself plenty of room because there's so much stuff we have to fit in there, right? So for president, we have Ben or Kylie. I'm just going to write B, and then I'm going to give myself some space, and I'm going to write K. Now for vice president, we've got Mike, Emma, and Adeline, and I'm going to list them for each that I have here. So for each of the president options, I'm going to relist the whole set of vice president. Kind of like what we did here. The red, orange, yellow, green, blue was repeated for the tails, right? Okay, so let me show you. Mike, Emma, and Adeline. So there's Mike, Emma, and Adeline. We're lining those up with Ben. And now we're going to write the same 3 and line them up with Kylie. Mike, Emma, and Adeline. Okay, there we go. So let's start making some branches. There. Just like that. Okay, and then we can write our possible outcomes over here. So I'll just draw some blanks. So this would be B and M. So Ben and Mike. This is BE. And this is BA. KM. KE. And then KA. So on all of these possible outcomes, we're going to have either Ben or Kylie for president, and then either Mike, Emma, or Adeline for vice president. So over here, create the tree diagram. Done. Now determine the total number of possible outcomes. 1, 2, 3, 4, 5, 6 possible outcomes there. So I'll write 6 right there. Now number 12, what is the probability that the president and vice president are girls? Well, let's see. Ben, Kylie. Kylie's a girl, right? Ben is not. Mike's a boy, but Emma and Adeline are both girls. So we need to figure out the probability of having Kylie and Emma or Kylie and Adeline. And where do we find that? Kylie and Emma right here, and Kylie and Adeline right there. So it looks like the probability of having a girl president and a girl vice president is going to be 2 out of 6. Which of course we then simplify. We're going to get 1/3. Okay, let's look at that next page. All right, this one's going to be all you. Let me get you started on it. It says an ice cream shop offers options according to the table below. So here's the flavors. You're going to have vanilla or strawberry. So that'll be like your first column over here in the tree diagram. Your toppings will be fudge, marshmallow, or butterscotch. Yum. And so that can be your second column, toppings. And then you're going to have a third column, a rainbow or cinnamon. Now, give yourself space, okay? Don't put vanilla and strawberry close to each other. I would put like vanilla here maybe, and then come down here for strawberry. You have all this space. You don't need it for anything else. And then for each of these 3, space out those 3 toppings. So you have fudge, marshmallow, and butterscotch. And then that repeats, fudge, marshmallow, butterscotch, there for the strawberry. And then sprinkles. you're going to have rainbow and cinnamon for each. So you might have rainbow, cinnamon, and so forth. Keep going down this way, and then you're going to draw your lines. All right, so like this, and it would keep on going. And then you'll figure out all your outcomes and answer the questions. So a lot of writing, but you know how to do this. Just kind of work methodically through it. And then we have the pizza one. This is my favorite, just because I love pizza. It says a tree diagram has been started to determine the sample space for ordering a one-topping pizza. It's amazing when you go to a restaurant how many different combinations there could be if you choose different toppings, different kinds of cheese, different crusts, all that stuff. So the options for crust are regular, deep dish, or thin. For cheese, you have mozzarella or 3 cheese. And then for the toppings, you have pepperoni, ham, chicken, or sausage. It says the same thing over here. It says to finish the tree diagram, list all the possible outcomes. That's just this right here. And answer the questions below. So first of all, we're just going to finish the tree diagram. We've already got arrows here, and it already says regular, mozzarella, pepperoni. So we'll just do the next thing. Regular, mozzarella. This time we're going to go to ham, right? And we'll put regular, mozzarella, ham. And then we're going to still do regular mozzarella, but this time we go to chicken. Regular mozzarella, chicken. And then still regular mozzarella, but we're going to go to sausage. Regular, mozzarella, and sausage. Okay, so now we're done with the regular and mozzarella with all of those toppings. Now we're going to go regular 3 cheese. Start with pepperoni. So regular, I'm going to write a 3 for 3 cheese. Whatever works for you. You could do a T. And then P for pepperoni. And then next, regular 3 cheese ham. Regular 3 cheese chicken. And regular 3 cheese sausage. Okay, once you're done with that, you're going to go down to deep dish and start this over again. Deep dish, mozzarella, ham. Oops, I forgot the pepperoni. There we go. So you would do deep dish, mozzarella, pepperoni, and just go from there. And then you're going to list the total number of outcomes, and then you're going to figure out some probabilities. Probabilities of not sausage, and the probabilities of deep dish and chicken. Okay, so that's that. If you have any questions, please let me know. Thanks so much for watching, and I will see you next time. Bye.